Weekly Robot News. Hello viewers, welcome back to your one-stop shop for all news robotics. We're back once more with the latest, sometimes shocking happenings of the robotic tech world. From iCub all grown up, robots getting inspired by Moai statues, and aid for field robots, all the way to a cute desktop robot and an e-nose to sniff out the best whiskey, we have it all and more. So, without further ado, let's jump right into our weekly updates. However, before we do, we request you to subscribe to our channel and press the bell icon to never miss another upload of ours. Having said that, let's get right to it. Highlights of the week. iCub is growing up. It's a little weird to think that iCub, the first version of which was released in 2008, is now a full-on teenager. After all, the robot was originally designed after a 3-year-old child, and it hasn't grown all that much. But, as it turns out, iCub has grown, at least a little bit, with the brand new iCub 3, a bigger, heavier, stronger upgrade that can also be used as a sophisticated immersive telepresence platform. You might not notice the difference between the old and new iCub unless they're standing side by side. But iCub 3 is 25 centimeters taller and weighs 19 kilograms more, featuring more powerful legs and rearranged actuators in the legs, torso, and shoulders. The head is the same, but the neck is a bit longer to make the robot more proportional overall. In total, iCub 3 is 1.25 meters tall and weighs 52 kilograms, with 54 degrees of freedom. Part of the reason for these upgrades is to turn iCub 3 into an avatar platform. That is, a humanoid robot that can embody a remote humanoid of the more biological type. This is something that researchers at the Italian Institute of Technology, or ITT, led by Daniele Pucci, have been working on for quite a while. Now, a couple of the shots right at the beginning of the video they released look more like drone videos than an actual representation of the user experience. Or, at least it won't be accurate until iCub can fly. Which they're working on, of course. It's also, honestly, kind of hard to tell what the user experience actually is just based on this very, very fancy video. And very, very fancy videos rarely inspire confidence about the capabilities of a robotic system. Fortunately, the researchers have published a paper on using iCub 3 as an avatar, which fortunately includes plenty of detail. Robots get inspiration from the Moai statues of Easter Island. People around the world have long been captivated by the Moai, a collection of statues that stand sentry along the coast of Easter Island. The statues are well known not just for their immense size and distinct facial features, for example, very broad noses and chins, but also for the mystery that shrouds their geographic location. The question that piques everyone's curiosity is, how did ancient Rapa Nui people move these ginormous rocks, some weighing as much as 80 tons, across distances of up to 18 kilometers? In 2011, a group of archaeologists made some progress in potentially unraveling this mystery. They conducted an experiment whereby 3 hemp ropes were tied to the head of a Moai replica. Using 2 of the ropes angled at the sides to rock the statue back and forth, and the 3rd rope for guidance, they were able to rock and walk the replica forward, demonstrating at least one possible way that the Rapa Nui people may have moved the real Moai so many centuries ago. In the experiment, 18 people were able to move a 4.35-ton replica 100 meters in just 40 minutes. More recently, a group of researchers sought to use robots to employ this rock and walk technique further. Jungwon Seo, an assistant professor at Hong Kong University of Science and Technology, has previously used robots to study how to precisely move and place go stones. Objects heavier than a go stone, like the Moai statue, may pose additional fresh challenges, but we were motivated by the difficulty, he says. His team devised a rock and walk technique and implemented it 4 different ways using single or dual robotic arms, or single or dual custom-made quadrotor aircrafts. They described their work in their study published on 21st January in IEEE Transactions on Robotics. WayFast for field robots. A new method of transversability predictive navigation for field robots has been developed. The team presents a self-supervised approach for learning to predict traversable paths for wheeled mobile robots that require good traction to navigate. Their algorithm, termed WayFast, Waypoint-free autonomous systems for traversability uses RGB and depth data, along with navigation experience, to autonomously generate traversable paths in outdoor unstructured environments. Their key inspiration is that traction can be estimated for rolling robots using kinodynamic models. Using traction estimates provided by an online receding horizon estimator, they are able to train a traversability prediction neural network in a self-supervised manner without requiring heuristics utilized by previous methods. They demonstrate the effectiveness of Wayfast through extensive field testing in varying environments, ranging from sandy, dry beaches to forest canopies and snow-covered grass fields. Their results clearly demonstrate that Wayfast can learn to avoid geometric obstacles as well as untraversable terrain, such as snow, which would be difficult to avoid with sensors that provide only geometric data, such as LiDAR. Furthermore, they also show that their training pipeline based on online traction estimates is more data efficient than other heuristic-based methods. ElectronBot, a sweet mini desktop robot that ticks all the boxes. Peng Shihui seems to have found some spare time and energy to crack out another sweet robot build. This time, it's a much smaller and cuter emoji bot with the usual production-ready levels of attention to detail. With a lot of fine details in the 3D printed models, this is one for SLS printing in nylon, but that can be done for a reasonable outlay, in China at least. The electronics package consists of a few full custom and tiny PCBs designed with Altium Designer with off-the-shelf modules for the circular LCD and camera. The main board hosts an STM32F405 and deals with the display and SD card. The reason for this choice of STM32 was due to the requirement for connecting to an external USB 3300 high-speed USB PHY. There is a sensor PCB which handles the gesture sensor, a USB hub, MPU 6050 9-axis sensor, and also the USB camera module. This board attaches to the USB-C connector in the base via a FFC cable, allowing the robot to rotate on its base. Peng clearly has exacting standards as to how things should work, and we guess wanted to have the arms backdrivable in a way that enabled the host computer to track and record the motor positions for replaying later on. The connection back to the controller is via I2C, allowing all 5 servos to hang on the same bus, saving precious resources. Smart! Getting a processor and motor driver in such a tiny space was a bit of a challenge, but a walk in the park for Peng, as he demonstrated in his video, which you might require English subtitles for. The arm mechanism is particularly interesting, and rather elegantly executed, and he does seem rather proud of this part of the design, and so he should. Like with Peng's other projects, there is a lot to see and plenty of scope for feature explosion. It was nice to see the bot being used as an input device, not only with gesture sensing via the dedicated sensor, but also using the camera with OpenCV to track user posture and act accordingly. This thing could act as genuinely useful AI device, as was being darn cute at the same time. eNose sniffs out the good whiskey. A whiskey connoisseur can take a whiff of a dram and know exactly the brand, region, and style of whiskey in hand. But how do our human noses compare to electronic noses in distinguishing the qualities of a whiskey? A study published 1st February in IEEE Sensors Journal describes a new eNose that is surprisingly accurate at analyzing whiskeys and can identify the brand of whiskey with more than 95% accuracy after just one whiff. eNoses have been gaining in popularity over recent years thanks to their range of valuable applications, from sensing when crops are ready for harvest to identifying food products on the cusp of expiring. It is perhaps unsurprising that many eNoses have also been developed to analyze alcoholic beverages, including whiskey, which had an estimated international market worth $58 billion in 2018 alone. This lucrative industry has the potential to be a target of fraudulent activities such as mislabeling and adulteration, explains Stephen Su, an associate professor at the Faculty of Engineering and IT, University of Technology, Sydney. Trained experts and experienced aficionados can easily tell the difference between whiskies from their scents, but it is quite difficult for most consumers, especially amateurs. Therefore, Su and his colleagues sought to adapt one of their eNoses so that it could analyze some key qualities of whiskey. Their original eNose was designed to detect illegal animal parts sold on the black market, such as rhino horns, and they have since also adapted their Enos for breath analysis and assessing food quality. With that, we come to the end of this video. Consider subscribing to join in on all the future fun.